All right, so I'm not going to do a proof of this for you. I'm just going to tell you these limits. So the first limit, these are limits you need to memorize right now. The first limit that you need to memorize is the limit as x goes to 0 of the sine of x over x, and that is equal to 1. The limit as x goes to 0 of the sine of x over x is equal to 1. And I thought I had a graphing calculator around here somewhere, but I bet it's in my backpack. I'm just going to grab one. Hope it works. All right, so if I wanted to graph sine of x divided by x Sorry, I'm taking so long on here. I just thought I'd try to get a graph so you can look at it. Okay, so here's kind of a graph of this function right here, the sine of x over x. Do you see the limit as x goes to 0 is what? Where's the y value? Where does it look like it's at? It's going to 1. I mean, I could hit the trace button, and at x equals 0, I mean, it's going to 1. See right next to it, it's 0.999. Technically right there, there's no y value, okay? But if you go to the left and right, the y values are 0.999 and 0.999. So, but the deal is if you try to plug 0 in, you'd get 0 over 0. Okay, so this is not a limit that you can work out by direct substitution. You do have to look at the graph to see that that limit is 1. All right, so this is a limit you need to memorize. Need to memorize it. Okay, and then there's another limit that you need to memorize. The limit as x goes to 0 of 1 minus cosine x over x, and that one is equal to 0. So hopefully you'll just take my word for it that that limit, that graph, it's as x goes to 0, the y value is going to 0. It's not actually ever going to get there because you're dividing by 0 every time, but that's where the lines will go. Now, something you need to understand about these two limit rules that you need to memorize, and in using them in the algebra, is that these have different forms, okay? So, like, we can use some of our properties of logarithms, or not logarithms, our properties of limits, to basically think of this in a little bit different way. Okay, so here's other things that are going to happen. You could, this function right here is still going to have a limit of 1 if it looks similar to all of these different things. If you were finding the limit as x goes to 0 of x over sine of x, that limit would still be 1. Okay, so you can do the reciprocal. Okay, the reciprocal of it, it's like taking it to the -1 power, and that would be the power property, the last exponent property. And you don't have to like prove all of this stuff. I'm just telling you things to be aware of. Okay, another thing that is nice is that this x doesn't just have to be x, that it could be like the sine of 3b over 3b. And as long as this thing on top, like the thing you're taking the sine of, is the same as this thing down here, that limit will still be 1. It could even be like the sine of 4x over 4x, as long as what you're taking the sine of matches everything on the bottom, that limit will also still be 1. Okay? So this, when you apply some of the properties of limits to it, allows you to have different forms of this. So it doesn't have to look exactly like this. That's what you need to keep in mind. So similar to this, okay, if I were to multiply this by like a -1, which is the scalar multiple property, then this might look like, instead of saying 1 minus cosine x, it would say cosine x minus 1. And that would still be equal to 0, okay, because of the property. I could also have the reciprocal of this. If I took all of this to the -1 power, it might look like this, and that limit would still also be 0. So those are things that you need to keep in mind when we're going to be looking at some trig limits. So now we want to look at some examples of how I'm going to use these limits and these little weird things that we just talked about to evaluate. All right, so let's take a look at find each limit. So let's say I want to find the limit as x goes to 0 of 5 times 1 minus the cosine of x over x. All right, so can I use direct substitution? Can I put 0 in? I can. Cosine of 0 is? No. 1. 1 minus 1. 0 times 5. 0 over, what form is that called? Indeterminate form. All right. So not going to work, correct? Okay, so what can I do? Well, here's where I'm really going to start using the properties and the two limits that you need to know. What I see is that this is a limit that I know, isn't it? And isn't 5 just a number? So if I know this limit and this is just a 5, I'm going to use that scalar multiple rule. I know the limit as x goes to 0 of this function is what? The limit as x goes to 0 of that is 0 times 5 is 0. That is the scalar multiple property of finding limits. All right, so what if I wanted to find the limit as x goes to 0 of the sine of x over 2x? Okay, so what part of this do I actually already know the limit of? So basically I'm just going to think of this, instead of the sine of x over 2x, aren't I going to think of it as 1/2 times the sine of x over x? And so this is another scalar multiple problem. So the scalar multiple problem says, well, I know the limit as x goes to 0 of this is what? 1. So my final answer would just be 1/2 times 1, or 1/2. All right, so now I'm really going to mess you up. Say I wanted to find the limit as x goes to 0 of the sine of 4x over x. Okay, so pay close attention here, because some of you try to make up rules on this. Okay, and you try to say that, oh, I could pull that 4 out in front. I'm not sure where you get that idea, but some people want to pull that 4 out in front. Nope, you can't do that. Okay, so I don't know the limit as x goes to 0 of this at all, because in order to apply that rule of sine x over x, this part here has to be the same as what's on the bottom. So what I'm actually going to do is I'm going to multiply this fraction by 1. So in order to make this into this, if I multiply the bottom by 4, I also multiply the top by 4, which now means I'm finding the limit as x goes to 0 of 4 sine of 4x over 4x. Now this part right here, I can now apply that limit theorem. What is this limit as x goes to 0? 1 times 4, which is 4.
Does x always have to be going to 0?
Yes, x always has to be going to 0 because they'll really try to like mesh you up on this section of your homework. I'll show you what they're going to try to do. They're going to try to say something like, what is the limit as alpha goes to 3 pi over 2 of the sine of x over x? Or sine of alpha over alpha. Just throwing in alpha. Alpha's like the same as x, okay? Beta, gamma, whatever Greek letter, theta, they decide to throw in there. Okay, so you might jump and say, oh, that's 1, but why would you be wrong? It's not going to 0. So what should I do instead? Substitution. So the sine of 3 pi over 2 divided by 3 pi over 2. What's the sine of 3 pi over 2? It's negative 1 divided by 3 pi over 2, which is negative 2 over 3 pi. And there's our limit. All right, so what if I wanted to find, I'm going to look at one more here. What if I wanted to find the limit as x goes to, say, 0 of tangent squared x over x? Okay, so substitution. What's the tangent of 0? It's 0. 0 squared? 0 divided by 0, indeterminate form, right? Okay, so what can I do? Well, tangent squared, gosh. What are my trig rules? Like if I were to ever be able to use one of those trig rules, what terms does it have to be in? Cosine or sine. Do you remember trig verification, trig simplifying? It's always best if it's in terms of sine and cosine. So what's tangent in terms of sine and cosine? Wouldn't this be, no, tangent is sine over cosine, right? Okay, so tangent would be sine squared x over cosine squared x. And then if I'm dividing that whole thing by x, wouldn't that be like sine squared x over x cosine squared x? Isn't that what I really have? Yeah? Okay, so here's where I'm actually going to use the property of the product property. I'm going to separate this. This is actually, I can write this as, isn't this all like sine squared? Doesn't that mean sine of x and sine of x times sine of x? Yes? Okay. And can't I put that x like on the bottom of, say, this one? And then times 1 over cosine squared of x? Is this the same as what I have there? Do I have sine squared on top? Do I have x cosine squared x on the bottom? So it's the same. So now the product property of limit says, if I have 3 things and I could find the limit as x goes to 0 of this, and the limit as x goes to 0 of this, and the limit as x goes to 0 of this, and they're all numbers, then I could multiply them together and get my whole answer. So what is the limit as x goes to 0 of sine x over x? It's 1. And the limit as x goes to 0 of sine x, can't I just plug 0 in? What's the sine of 0? It's 0. Is 0 okay? 0 is not indeterminate form. It's just 0, not 0 over 0. All right, what's the cosine of 0? 1. 1 squared is 1. 1 divided by 1 is 1. So what's 1 times 0 times 1? 0. And it's okay because I'm not trying to divide by 0 too. So that's about as complicated as your homework will get. Very briefly, the squeeze theorem.